When we think about what makes a car go, we usually think about the engine, right? But that's not the whole story anymore. Not even close. There's this invisible revolution happening under the skin of modern cars, and it's changing their very DNA. So let's dive into the hidden system that's completely redefining what a car is and what it's about to become. I want you to just think about this for a second. What if your car didn't just get older, but actually got better the longer you owned it? I mean, what if it could get faster, more efficient, or even gain brand new features, all while it's just sitting in your garage? Well, that's not science fiction. It's the very real promise of the technology we're going to break down today. The magic behind all of this is something called E/E architecture. That's short for electrical and electronic architecture. The best way to think about it is as the car's central nervous system. It's this incredibly complex network of hardware, software, and all the wiring that lets every single electronic part talk to each other and work together, hopefully in perfect harmony. So, to really get where we're going, we first have to understand where we've been. For decades, cars were built using an architecture that, honestly, is now a total dead end. It's the very reason why most cars on the road today simply can't get any smarter than they were the day they were built. See, the old way is called a distributed architecture, and you can picture it like this. Your car has dozens of tiny, separate mini brains. Each one is called an electronic control unit, or an ECU, and every single ECU has just one job. You've got one for the engine, the ECM, one for the brakes, the BCM, another for the airbags, the ACU, and then dozens, and I mean dozens more, for everything else. The dashboard, the keys, the headlights, you name it. So what's the problem with having all these little mini brains running around? Well, they all need to talk to each other, and this created what engineers literally call the wiring harness nightmare. It's this gigantic, heavy, and unbelievably complex spiderweb of wires that has to snake its way through the entire car. It's expensive to make, a pain to assemble, and it adds a ton of weight. And that nightmare led to the real roadblock, software gridlock. Think about it. With all these little boxes coming from different suppliers, each with its own unique software, trying to update them all together is basically impossible. If you wanted to add a new feature, you had to add another box and even more wires. The whole system was just fundamentally inflexible, and it made this dream of a software-defined vehicle a complete non-starter. All right, so that brings us to the solution, a central master brain. Now, the company that really pioneered this was Tesla, and they had a huge advantage. They were starting from a completely clean slate. No gold factories, no legacy supply chains to worry about. They could just rethink the car from the ground up, and this shift to a centralized architecture absolutely changed the game. So, just how much simpler did things get? Check out this number, 4. While those traditional cars were juggling dozens and dozens of ECUs, the Tesla Model 3 uses just 4 main control units to manage the entire vehicle. That is nothing short of a revolution in simplification. And look, this simplification wasn't just about being neat and tidy. It was the key that unlocked true over-the-air updates. And I'm not talking about the kind that just fixes a little bug on your infotainment screen. I'm talking about updates that can genuinely improve your car's acceleration or add brand new driving features years after you've driven it off the lot. Okay, so the rest of the industry has definitely taken notice, but for the big traditional automakers, making this kind of change is a massive, massive challenge. I mean, it completely upends their entire supply chain, which was built around buying all those little electronic boxes from hundreds of different suppliers. So they're playing catch-up, and they're doing it by taking 2 very different paths. You can really think of this as the evolution of the car's nervous system. We started in that tangled past, with the distributed architecture. Right now, most car makers are in the middle, using what's called a domain architecture. It's kind of like a practical bridge to get them to the next step. But the ultimate goal for everyone is something called zonal. So what's the difference between these 2 new approaches? Well, a domain architecture groups the car's computers by their job, kind of like departments in a company. You have one for infotainment, one for safety, and so on. It's a great first step because it reduces the number of ECUs, but the wiring is still a huge headache. The endgame is the zonal architecture. This organizes everything by physical location in the car, so you have a powerful computer in the front that manages everything in that zone. This massively simplifies the wiring, but it's a huge challenge because it means you have to completely redesign the vehicle from scratch. Okay, I know, we've waded through a lot of technical stuff, but let's get to the important part. What does all this actually mean for you, the driver? Well, it means your car is fundamentally changing from a static piece of machinery into a dynamic, upgradable piece of technology, just like your phone.
This is all possible because of a really cool concept called hardware-software decoupling. Think about your smartphone for a second. When Apple releases a new iOS update, it works on a bunch of different iPhone models, right? That's because the software is decoupled or separated from the specific hardware. Well, the exact same thing is now happening to cars. That central master brain can get new software that improves the entire vehicle, not just one little part.
And this whole new setup enables two totally different kinds of updates. You've probably heard of SOTA, which is software over the air. This is for stuff like getting new maps, new apps for your screen, or fixing bugs in the infotainment. But the real game changer is FOTA. That's firmware over the air. A FOTA update can actually change the car's core programming. It can give you better acceleration or squeeze more range out of your battery. That right there is where the real magic happens.
So the payoff for us drivers is just huge. First, as we said, your car actually gets better with age. Second, this powerful centralized brain is the absolute non-negotiable foundation for real, true self-driving technology. And third, all of this together represents a complete revolution in the very idea of what a car even is. So let's wrap this up. What we've been looking at today, it isn't just some minor tweak or a small upgrade. This massive architectural shift is literally the blueprint for the future of cars. It's a fundamental change to their DNA.
And the stakes could not be higher. One industry analysis I saw put it perfectly. The race to perfect this new automotive nervous system is on, and it will undoubtedly define the winners and losers in the future of the automotive industry. This isn't just about cool features anymore. For car companies, this is about survival.
So, as this incredible technology becomes the new normal, it leaves us with a really fun question to think about. If you could download any feature, any upgrade to your car with just the push of a button, what would you choose first?